So in today's lecture of integral equation, I will be teaching you all Poincare-Bertrand transformation formula, okay? And in this holders condition, continuous function, then Cauchy integral equation, Lipschitz condition, and Clemage formula will be used, okay, in this. So let me start. In the exam, they can ask you all state and prove Poincare-Bertrand transformation formula, okay? In exam, they can ask you all this. So, if they ask you all to state and prove, then you all have to state. Let y of t be Holder's continuous function and c be the closed contour. Then this will happen, okay? This is the statement of Poincare-Bertrand transformation formula, okay? This part I will write on the next page, the same thing, this equation formula, okay? So I have written it over here, okay? 1 upon 2 pi the whole square integral from c to star dxi1 upon xi1 minus t into integral of c to star y of xi upon xi minus xi1 d of xi is equal to 1 upon 4 into y of t. Okay, now let me start with the proof now. So let y1 of t is equal to 1 upon 2 pi I. Take this y1 of t as 1 upon 2 pi into integral of c to star y xi upon xi minus t dxi. Take this as 1 and y2 of t is equal to 1 upon 2 pi integral from c to star y1 of xi. So for y2 of xi, what we'll do, wherever there is y of xi, I will be putting y1 of xi, okay? See, take this as y1 of xi upon xi minus t into dxi. You can consider this as 2. So what is the difference here? Just y of xi is there and here it is y1 of xi, okay? So that's the only difference. Okay, now I'll turn the page. Now equation 1 and 2. Now this equation and this equation 1 and 2 be two singular integrals where y1 and y2 are two Holder's continuous function. So y1 and y2, now this and this are my two Holder's continuous function, okay? Now consider f of z. Now this is from Cauchy integral, right? F of z is equal to 1 upon 2 pi integral from c y of xi upon xi minus z dxi, okay? And take this as equation 3 and f1 of z. Now take f1 of z is equal to 1 upon 2 pi I. Same thing, integral from c y1 of xi. Here just y of xi was there, y1 of xi upon xi minus z dxi, okay? Just don't forget to put like this, okay? I have not put, but you all can put it, okay? I just forgot. Anyways, now take it as 3 and 4. This z part I was saying, just put that dash thing. Otherwise it's fine. Next, by using Clemage formula. In the previous video I have already taught you all what is Clemage formula, what is Holder's continuous function, what is the Holder's condition, continuous function, everything I have already taught you all. So f plus of t, now take the Clemage formula, f plus of t is equal to 1 upon 2 half into y of t plus 1 upon 2 pi integral from c to star y xi upon xi minus t dxi, and take this as 5. And what is f1 of this plus of t is equal to half y1 of t plus 1 upon 2 pi integral from c to star y1 of xi upon xi minus t dxi, and take this as 6, okay? Now I will compare 1 and 5. Now I have to compare this 1 and 5, this one, okay? Now let's see what we get. So I will get y1 of t is equal to f plus of t minus half y of t, okay? Okay, now I'll tell you all how I got this part, okay? y1 of t is equal to, see, f of t is equal to half y of t is there, right? F plus of t, this minus, this I brought it this side, so it will become minus half y of t. Now what I have done for this, what is 1 upon 2 pi integral from c to star this from equation 1. So what is my equation 1 over here? Yeah, this one. So what is my y1 of t? Nothing but 1 upon 2 pi, this equation, okay? So I have to, what it is? Y1 of t. So that's what I have done. This is y1 of t is equal to, this part is my y1 of t. From equation 1 I got this, okay? I have to substitute that one in this. Now I'll turn the page. Similarly, I'll have to compare 2 and 6. Meaning I have to compare this. Now what is my 1 upon 2 pi? This y1 of xi upon xi minus t d into dxi is nothing but, I have to compare it with 2, no? y2 of t, this. That you have to substitute in 6. This one. So I will get y2 of t is equal to f1 plus of t minus half y1 of t, and take this as 8, okay? Now you will have to consider from 7. Now consider this, and wherever there is t, replace it by xi. So y1 of xi is equal to f plus of xi minus half y of xi, and take this as 9. Now you will have to substitute y1 of xi in 5. So you all have to substitute this value in equation 5. In this equation, okay? Wherever there is y of xi, there you all have to substitute, okay? Sorry, wait. Equation 5 I said, right? So I made a slight mistake over here. This is, I have to substitute in this. This is 4, okay? It is 4. So this is 4, okay? Okay, now I have to substitute y1 of xi in 4. So what I am going to get is, in 4 meaning in this I have to substitute. f1 of z is equal to 1 upon 2 pi y1 of xi. In this I have to substitute this. The value of this. So what I am going to get is this. f1 of z is equal to 1 upon 2 pi integral from c f plus of xi minus half f y of xi d of xi upon, this is what xi minus z. Now f1 of z is equal to what? Write this 1 upon 2 pi. Now multiply this, I will multiply with this, as well as this I will multiply with this, okay? I will separate the terms, integrals, okay? So 1 upon 2 pi into this. Integral of c f plus of epsilon upon this minus this into this is what? Minus 1 upon 2 pi 4 pi I integral from c y xi upon xi minus this xi minus z into dxi xi, okay? Now since f plus of xi is the limiting value of f of z, now this is the limiting value of this, okay, f of z, which is regular inside C using Cauchy integral formula. Now we will be using Cauchy integral formula. So what we are going to get is f of z is equal to 1 upon 2 pi integral from C f plus of xi upon xi minus z dxi, also 1 upon 4 pi integral from C y of xi upon xi minus z d of xi is equal to half into f of z. Now consider 10. Now these values, this whatever these values, I will substitute in this 10, okay? Okay, I'll turn the page now and I will start substituting this part. Right, f1 of z as it is, okay? Here f1 of z is equal to, what was there here? 1 upon 2 pi integral from this f plus of xi upon xi minus z is what? Is nothing but into dxi, right? Yeah, and it is what? It is nothing but f of z. So plug it over here, f of z minus half into f of z. Why? How I got this? What is the value of this? Half f of z, okay? That I have to, this it is, 1 upon, minus sign, right as it is, 1 upon 4 pi integral from c y xi upon xi minus z into dxi is nothing but half f of z. So write minus half f of z, okay? Then if you take this to this side, suppose if I take this to the other side, it will become 2f of z minus upon 2, okay, and this is minus f of z, right? So what I'm going to get is f of z, just 1 f of z upon 2 I'm going to get, okay? So that I'm going to write it as f of 2 into f of z, right? So let me clean this part. I have just explained you all this part, like how I got this f1 of z is equal to half f of z, okay? And one more thing, just do one correction I want you all to do. Where it is, somewhere here it was. Yeah, just do correction for this. This dxi, you all write it, okay, here. This for this one also. Minus and this. Okay. Just write down, after this, write dxi minus 1 upon 4 pi into this, okay. Now, okay, so after this step, f1 of z is equal to half. I told you all how I got this f of z into f of z, and f1 plus of t. Now just make this as plus and then replace this by t. Wherever that is z, just put it t, okay? And f, I have to change it into plus. So f1 of plus of t is equal to half f plus of t, and consider this as equation 11, okay? So from 8 we get, now see what is my equation 8 over here. y2 of t is equal to this, right? So what we are going to get from this equation? Now write this equation 8 here. So I have written equation 8 over here. Now y2 of t, write it as it is equal to 1 by 2. Now what is my f1 plus of t? Just look at equation 11. What is f1 plus of t? Is nothing but half into f plus of t. Half into f plus of t minus half, right as it is. And what is my y1 of t? From 7, what, just see by 7 what you are getting. Equation 7. Yeah. What is my y1 of t? F plus of t minus half into y of t, right? That thing you all have to write it here. This. F plus of t minus half into y of t. So this I am getting by 7 and 11. So now this implies what? y2 of t is equal to half into y of t star, okay? Now see here, half f plus of t minus half f plus of t will get cancelled, it will become 0. Now this minus half will multiply with this, so you will get what? Plus, now positive 1 by 4 into y of t. That's what I have written it here, okay? And take this as star. Next I'll turn the page. Now from 2, what you all do is, so from 2 you all take, see, this is my equation 2, right? So wherever there is xi, no, just replace it by xi1. Just you'll have to put 1 over here in front, okay? So I'll turn the page. See, y2 of t is equal to 1 upon 2 pi integral from c to star. I have just replaced my xi to xi1 I made, okay? y1 of xi1 upon xi1 minus t dxi1, okay? Consider this equation as 12. Take it as 12. Now from 1 what you all will get? y1 of, so from 1 what I have, so from 1 what I have did is, what I've done is, wherever there is t, see wherever there is t, I have to replace it by xi1. Okay, so let me turn the pages. Yeah, so y1 of xi1 is equal to 1 upon 2 pi integral from c to star y of xi upon xi minus xi1. So wherever there was t, I have replaced it by xi1 into dxi and take this as 13. So substitute y1 of xi. Now you will have to substitute this value in this y2 of t, and let's see what we get. So what I have done over here, I have substituted this y1 of xi1 in this y2 of t. Okay, over here y2 of t is equal to 1 upon 2 pi integral from c to star 1 upon xi1 minus t into this 1 upon 2 pi integral from c to star y xi upon xi minus xi1 dxi into dxi1. Okay, now this into this I have made first. Okay, so it will be 1 upon 2 pi the whole square integral from c to star. Now this dxi1 I have brought it over here upon xi1 minus t, then integral from c to star, this I have already done this into this. So y of xi upon xi minus xi1 into dxi. Now from star, what we got from star, y2 of t is equal to half y of t, write it as it is here. Then substitute the value of y2 of t, this whatever you got in place of this, and then is equal to half 1 upon 4 y of t. So what is my y2 of t? 1 upon 2 pi the whole square integral from c to star t xi 1 upon xi1 minus t integral from c to star y of xi upon xi minus xi1 d of xi is equal to half into y of t. So I am done with today's lecture on teaching all that poincare-bertrand transformation formula. If you have not understood any of the concept in this, you all can just comment below. I can explain you all again if you all want. Okay. So now we finally found out the formula for the poincare-bertrand transformation formula. Okay, this is, so we were supposed to find this, right? This one. So finally we found out this. Okay, and with this we are done. You all can go to it and please learn this. And thanks for watching.